Today we're going to investigate special triangles, and our purpose for special triangles is that we can find answers with exact values. So it's going to be important that we remember all of our work with radicals and rational numbers from last unit. It's always good for the trigonometry lessons that we're doing in the videos to have your calculator nearby to maybe pause and do some work with us to be sure that you can use your calculator appropriately as well as understanding the concepts. So there's going to be two triangles we're going to look at. The first one being a right isosceles triangle. And a right isosceles triangle means that there's a right angle in it, a 90-degree angle, and two sides are equal. And that's what we have drawn here for you. So just remember that all angles added together in a triangle equal 180 degrees. So if this angle down here is 90 degrees, get rid of that, then our other angle up top here must be 45 degrees as well, because they all have to equal 180. So 45 plus 45 is 90, plus another 90 is 180. So now if we're going to determine sine 45, and to determine it means to find the ratio. And we're not going to put it into our calculator and make any decimals. We're going to leave everything exact. So our first one, remember that sine is always going to be opposite over hypotenuse. So our ratio for sine 45 is 1. And then when we look at our diagram, we realize we don't know the hypotenuse. But this is easy for us to do because of the Pythagorean theorem yesterday. Remember, a squared plus b squared equals c squared. So we have 1 plus 1 equals c squared. So we have the square root of 2 is length c. So over here is the square root of 2. So now we have enough information that we can find that ratio. If you can see up top here in our note, it's saying that our textbook shows this a little bit differently. And what our textbook does here, so that there's no square root sign in the denominator, they multiply both the top and the bottom by the square root of 2. Now, first of all, they can do that because it doesn't change the value at all. Keep in mind that the square root of 2 over the square root of 2 is equal to 1. So we can multiply anything by 1 and it doesn't change the value. The reason you do that is because if you multiply two square roots together, they will cancel each other out because we're going to have the square root of 4 in the denominator and the square root of 4 is 2. So what we're left with if we simplify this is sine 45 equals the square root of 2 over 2. So we still have a radical, but we've put it in the numerator instead, and that helps us when we're solving other questions that you'll see in the future. So for cos 45, we have adjacent over hypotenuse. So for cos 45, we have 1 over the square root of 2 as well. And if we multiplied both of those by the square root of 2 and the square root of 2, we would end up with the square root of 2 over 2. Lastly is tan 45. And that's opposite over adjacent. So tan 45 is 1 over 1. And that simplifies to just be 1, of course. So these ratios that we have down here are going to be really important for us to use in questions that come up in the future. And the more you use them, the more you're going to remember them and have them memorized. It is going to be your responsibility to have them memorized, but it shouldn't be so much a memorization as an understanding because you can now picture this triangle here and where the ratios actually came from. Memorizing is never a good thing. It's always good to understand where they came from, so on a test you don't have a lot to memorize at that point. Now that we've looked at an isosceles triangle, we're going to look at an equilateral triangle. Equilateral triangle being that all the sides are equal. If all the sides are equal, so are the angles. So that means if we look at this triangle as a whole, here this whole triangle, ABD, all our angles in here are all 60 degrees. If we were to split this triangle in half, then this angle was split in half, it was 60. It's now 30 90, and that one still is 60. It's untouched. I'm just going to make that more of a 3 there if I can. There. And that angle there's 30. So down here, if it's an equilateral triangle from B to D, must also be 2 units long. If we're splitting that triangle in half, this must be 1 unit long. We don't know what length AC is, but because of Pythagorean theorem again, we can quickly find that. Again, we're going to want to leave all of our numbers whole. No rounding. So it's going to be, oops, let's just clean this up. Small mistake there. Okay, we'll substitute it again. The legs is 1 squared plus B squared, and it's important to be sure that that 2 always goes into C. So I have B squared equals 4 minus 1. Therefore, B must be the square root of 3. The square root of 3. So we're going to do some of the same work that we did when we were using the isosceles triangle. We're going to find our ratio for 30 degrees and 60 degrees. Then we're going to know all our special triangles for 45, 30, and 60 degrees. So we'll start with our 30. So if I had sine 30 equals opposite over hypotenuse, sine 30 is 1 over the square root of 3. Again, we want to get that radical out of the denominator, so I'm going to multiply them both by the square root of 3, leaving me with sine 30 equals the square root of 3 over 3. So if we do cos 30, that's adjacent over hypotenuse. Cos 30 equals the square root of 3 over 2. And then last, of course, for our 30 degrees is tan, which is opposite over adjacent, which is 1 over the square root of 3. Take that out of the denominator, and we're left with tan 30 equals the square root of 3 over 3. So let's highlight for your notes your important ratios you need to know. So for sine 30, it's going to be important to know that it is the ratio of that is square root of 3 over 3. For cos 30, it's the square root of 3 over 2. And for tan 30, square root of 3 over 3. You can always visualize these triangles so you don't have to. Okay, now we're going to do the same work for our sine 60, cos 60, tan 60. So for sine 60 degrees, that's opposite over hypotenuse. So that's the square root of 3 over 2. Cos 60 is adjacent over hypotenuse, which equals 1/2. And tan 60 is opposite over adjacent. So our tan 60 is just the square root of 3. So again, I'll highlight these ones that are important. Our 60s are the ratios that you need to know. I have a summary chart down below here. Have a look. That's a good way to build in your notes to keep it organized for yourself as well. So you can see everything that is 30 degrees, everything that's 60 degrees, and everything that is 45 degrees. So the expectation now will be that you can do these questions without a calculator because you now know what all of the ratios are. For example here, tan 30 we know is the square root of 3 over 3. That's what the ratio is. Sine 60, square root of 3 over 2, plus cos 45. Oops, we can see we have a little typo there. That one there should be cos and tan. So our cos is the square root of 2 over 2. Now let's just remember distributive property works that you multiply the outside term by the inside term, and being careful of your radical rules as well. So the square root of 3 times the square root of 3 is the square root of 9, and we know that equals just 3. So we can do less steps now, some of our work. 3 times 2 here is 6. And then we do the distributive property again. Square root of 3 times the square root of 2 is the square root of 6. 3 times 2 equals 6. We have like terms, so we have a final answer of 3 plus the square root of 6 all over 6. And I shouldn't say that we have like terms there. We have common denominators. The numerator is not like terms, so I cannot simplify that any further. That's our final answer there. I put in 2 more examples for us to do here that we can still solve without a calculator. So we just keep in mind our algebra. Our cos theta is our unknown. So that's what we need to isolate for. Just think of it as an x as well, that you're isolating for. So if I divide this side by 16, these cancel out, and whatever you do to one side, you do to the other. So what I have here, keep putting that equal sign in the wrong spot, 1 second. What I have is cos theta equals 8 times 6, 8 over 16 reduces to 1/2 square root of 2. So theta must be equal to the square root of 2 over 2 for cos. Let's have a look. Look up here. Square root of 2 over 2 is equal to 45 degrees. So we can now solve for angles as well with the help of these ratios. Here, if I was looking for theta, I know the opposite side and the hypotenuse, so I have a sine ratio. Sine theta is 5 over 10. That theta reduces to 1, that ratio reduces to 1/2. So sine theta is 1/2. And where we see 1/2 with sine is right there. So we know that theta must be 30 degrees. No longer needing to use the inverse button on our calculator. There it is there. So we'll do more of these questions in class tomorrow.